Okay, so the question is the acid dissociation constant of a weak acid HA has a value of 1 into 10 to the power minus 5 moles per dm cube. What is the pH of a 0.1 mole per dm cube aqueous solution of HA? So HA is a weak acid, so it partially dissociates into H plus ion and A negative ion. Ka is given, acid dissociation constant 10 to the power minus 5 mole per dm cube. So we can write the acid dissociation constant equation divided by concentration of E. So this is my equilibrium constant Ka, which is the acid dissociation constant. So 1 mole of H plus and 1 mole of A negative is formed from dissociation of HA, partial dissociation of HA. So in the dissociated solution we will have equal concentration of H plus ion and A negative ion. So if we consider them as X, so this formula reduces to Ka equals to X square over concentration HA. Now the initial concentration of HA is given to us, which is 0.1 mole per dm cube. Now since HA is a weak acid, we can see from the Ka value, this is 10 to the power minus 5 moles per dm cube. So we can consider that the concentration of HA is same as 0.1 mole per dm cube. So in this equation we have Ka, we have concentration HA, we can find out X square. So 10 to the power minus 5 equals to X square over HA. So X comes out to be square root of 10 to the power minus 5 multiply 10 to the power minus 1. So that is a square root of 10 to the power minus 6. So we have to find the pH of this solution. So in order to find pH, we know that pH equals to minus log to the base 10 of H plus ion concentration. Now what is H plus ion concentration? It is X, and X is this value we have calculated. So this is minus log to the base 10 of square root of 10 to the power minus 6, and this comes out to be 3. So this is the answer. So the correct answer is option B. Okay, so the question is which mixture will produce a buffer solution when dissolved in 1 dm cube of water? Option A, in option A it is given that 0.3 moles of ammonia and 0.3 moles of HCl. So what is the reaction between ammonia and HCl? Ammonia plus HCl gives ammonium chloride. So it is given that 0.3 moles of ammonia and 0.3 moles of HCl. So since the moles ratios are same, 1 mole react with 1 mole of HCl, so 0.3 mole will react with 0.3 mole to produce 0.3 moles of ammonium chloride, and nothing will be left. So we will only have this at the end of the day. So this is not a buffer. So option A is not right. How about option B? In option B, again we have 0.3 moles of ammonia and we have 0.15 moles of HCl. Now since ammonia and HCl reacts in 1:1 ratio to give 1 mole of ammonium chloride, so HCl is our limiting reagent and ammonia is our access. So we will get 0.15 moles of ammonium chloride and the leftover will be 0.15 mole of ammonia. So this is a buffer, this is a buffer. So the correct option is option B. So the question is stomach juices have a pH of 1.0. Aspirin is a monobasic acid represented by HA. The value of Ka is given. which dissociate into ions H positive and A negative. What are the relative concentrations of H plus and A negative and HA when aspirin from a tablet enters the stomach? So the pH is given to you for the stomach juice. pH is 1.0. So from this pH we know that H plus ion concentration of the stomach juice will be 10 to the power minus pH, that is this. So 10 to the power minus 1 moles per dm cube. So this is the H plus ion concentration in the stomach juice. Now aspirin is denoted by HA, which is a weak acid. How do we know that this is a weak acid? Because Ka value is 10 to the power minus 4, which is far less than 1 moles per dm cube, and Ka is H plus ion concentration multiplied by A negative concentration over concentration of HA. Since this Ka value is less than 1, so it means our HA concentration is far bigger than the concentration of H plus and A negative. So equilibrium is more towards the left hand side. So the concentration of HA is far greater than the concentration of H plus ion or A negative ion from this equation. So we can say the concentration of HA is greater than concentration of A negative ion. Now when HA will partially dissociate, it will give H plus ion as well as A negative ion. So we are increasing the H plus ion further. So this H plus ion from the dissociation of HA will also add up in the concentration of H plus ion from the stomach juice. So therefore the concentration of H plus ion will be far greater than concentration of HA, and this will be far greater than A negative. So this is the order of the concentration. So the correct option is option A. Okay, so the question is, what is the final pH of a solution found by mixing equal volumes of two separate solutions of pH 2.0 and 4.0? So pH of first solution is 2.0. So from here we know the H plus ion concentration will be 10 to the power minus pH, right? So this is moles per dm cube. And from the pH, second solution pH is 4.0. From here we know the concentration of H plus ion will be 10 to the power minus pH moles per dm cube. Now let us assume the volume of this solution is V and the volume of this solution is V, because they said that they are mixing equal volumes of two. So therefore we considered V and V. So what will be the total volume? Total volume will be 2V, V plus V, 2V. So for first solution, can we find the moles of H plus ion? So moles will be concentration into volume. Concentration is 10 to the power minus 2 and volume is V. Similarly, can we find the moles of H plus ion in solution 2? Concentration into volume. Concentration is 10 to the power minus 4 and volume is V. So now what are the total moles? Total moles when both the solutions are added. So this will be this mole and this mole. We will add both of them. So this will be 10 to the power minus 2 V plus 10 to the power minus 4 V. So this will be 0.01 plus 0.0001 times V. We take out V outside. So these are our total moles and this is our total volume. So can we find the concentration of H plus ion in the final solution? Concentration is moles upon volume, so that will be total moles 0.01 plus 0.0001 times V divided by total volume is 2V. So V cancels out. So this is our concentration of H plus ion. So now we need to find the pH. So the pH will be negative log to the base 10 of H plus ion concentration. So this concentration is 0.01 plus 0.0001 divided by 2. So this comes out to be 2.3 pH. So the correct answer is option B.